get to it. So, okay. First, you can see what's underlined in purple to make your life easy is what you are filling in on the blanks on the notes. So let me give you a minute to fill in the words, and then I'm going to explain this to you, because this to me is very wordy for something very simple. So the purple is what you got to fill in. So a dilation is a transformation in which a figure is enlarged or reduced. We talked about that. With aspect to a fixed point C called the center of dilation and a scale factor K. Now we're going to talk about this scale factor K here in a minute, of course, which is the ratio of the lengths of the corresponding sides of the image and the pre-image. So meaning, if your scale factor, let's say, is 4, you just times all the coordinates by 4 and your picture will be 4 times the size. That's what we're going to be working on today. We got those filled in, because I know there's more. Clearly I couldn't fit all of that on one slide. Next up. So, reading there at the asterisk, a dilation with center of dilation C and scale factor K maps every point P in a figure to a point P prime, so the following are true. So part A, if P is the center point C, then P equals P prime. So you have to fill in what is in red on that blank on A. For that. B, if P is not the center point, then the image point P prime lines on CP. The scale factor K is a positive number such that, and you have to fill in, I don't know, hopefully you can see the yellow, what is circled in yellow. I'm going to talk about that because that even looks confusing to me. And then of course part C, angle measures are preserved. And then fill in, let's just fill it all in and talk about it. At the bottom, when the scale factor K is greater than 1, it's called an enlargement. If it's between 0 and 1, we call it a reduction. So let me give you a minute to fill in all the blanks, and then we'll talk about it all. This is incredibly, I think, wordy. I really should just write my own textbook. Very wordy for something very simple, okay? So if your scale factor is over 1, like 4, it's going to make the picture 4 times the size. It enlarges it. If your scale factor is between 0 and 1, let's say a half, well, it shrinks it. Your picture is half the size, or what we call that, of course, is a reduction. So that's what that amounts to. Now, other thing up here I'm going to add to this. This, to me, looks confusing, I think. So when you were trying to figure out the scale factor, so here's the thing. Remember, prime is your image. When you don't have the little tick mark, the prime on it, that's your pre-image. So all you're doing is you're comparing the image to your original picture, the pre-image. So that's really what I wrote in green, what I think of or how I calculate K. I'm not like, oh, is it C to P or P to P? I just think it's the image to the original starting pre-image. Just like on that percent problem that we just went over, that percent of decrease, we divided by the original amount. Same thing here, you're dividing by the original picture, what we call the pre-image. So here we go, super easy. So find the scale factor, fraction, here we go, and then we'll tell if it is, of course, an enlargement or reduction. So first thing I want to know is to the image. How long is it to the prime? Clearly you can look at the picture, it's 12. And then I compare that to the pre-image, the original picture, which is 8. Now we should reduce that. What's 12 over 8 reduced to? 6
over 4.
Reduce it again.
3 over 2.
Got it. And then the next question is that an enlargement or a reduction? Well, 2 ways to figure it out. I mean, look at the picture. Here's the image with the prime on it. Here's the starting one. Enlargement or reduction? Is it getting bigger or smaller? Bigger, so enlargement. Now, it also, another way to tell that, 3 over 2, of course, mixed number style, I know we love our fractions, is 1.5. Remember, anytime the scale factor is over 1, it enlarges the picture. Okay, let's look at B. Same thing, let's set up our fraction. Now again, we just have to look very closely at the picture. To the image first. So really, you got a 50-50 here. Is it 30 over 18 or 18 over 30? The image is which one? The one with the prime or without? with the prime is the image. So 18 without the prime is your starting point, the pre-image, so 30. Okay, let's reduce that. What does that reduce down to? Go down the fractions, Dean. Okay, enlargement or reduction? Reduction. Clearly you can look at the picture and see the prime one, what you end up with is getting smaller, or know your fractions. 3/5 is between 0 and 1. All right, you guys are up, flip the page. Now, I was kind of mean to you. I didn't give you a picture. So you're gonna read close. Ooh. So you need to decide, is it 3/12 or 12/3? All right, what'd you decide on? 3/12 or 12/3? 3/12 to the prime first. All right, let's reduce it. 3/12, of course, a quarter. Reduction or enlargement? Reduction. It's a quarter as much. It's going to shrink it down. That's the tricky, and I say that kind of tongue-in-cheek there, tricky part of the day, which is pretty easy. Always go to the prime first and then the pre-image. Rest? Easy. Okay, nothing to fill in on the note sheet, just look at it. So we're going to talk about how to use the rule, the coordinate rule for dilations. It sounds very fancy. All you are doing, notice I put these very lovely purple dramatic dots in here just to point out to you that you are multiplying between k and x and k and y. So you multiply all the coordinates by the scale factor. So here, your scale factor is 2. I'm going to eventually multiply all of that stuff by 2. But first I'm going to start plotting my original triangle here. So A is at 2, 1. As always, make sure you label the points. B, 4, 1. And C, 4, -1. Got it. Now, scale factor of 2. First question, is that going to enlarge my picture or shrink my picture? Enlarge. So all I have to do to get my other coordinates, A prime, B prime, C prime, a little mental math here, I'm going to multiply everything up there by 2. 2 times 2, 2 times 1. 2 times 4, 2 times 1. 2 times 4, 2 times -1. Now when I plot those green coordinates, it should be twice as big. Say 8, -2. Got it. Does the green look twice as big? Sure, sure. So it is an enlargement, and this is how we do a dilation. Quick vocab check for you. Is this an isometry? Nope, sure not. What does isometry mean? Stays the same shape and size. This clearly is not. We're finally off an isometry. Okay, let's do the next one. Ooh, a fraction. Here we go, kids. Okay. So again, let's first plot the original one. K -3, 6. L at 0, 6. M at 3, 3. -3. Okay, all right. Here we go, fraction time. I'm scared a little bit. So now we're timesing everything by 1/3. What's -3 times 1/3? You don't need a calculator for it. What happens to the 3's? Yeah. What's a 6 times a third? 2. All right, let's do L prime. Well, third times 0, that's easy. 0. 6 times a third, we just did that. What is 3 times a third? And then, of course, -3 times a third, -1. Okay, we plot these. It better be a third the size or something bad has happened. A prime. Oh, no, looking good, looking good. There we go. This is the majority of your homework, is multiplying the coordinates and graphing it. Any questions on those? All right, flip it then. Home stretch already. Now, next thing, this is not a big deal, it's still the same process. What if they get fancy and throw a negative on your scale factor? Let's talk about it. So, purple is what you have to fill in on the blanks, and the green, so let me give you a minute to fill in the blanks. Let's do that. And believe it or not, we're almost done. So in the coordinate plane, you can have scale factors that are negatives. When this occurs, it also results in a rotation of 180 degrees. So you can see, it's still up here on the board, so your 180, we have the negatives on both of the coordinates. We switch the signs on both of them. So that's going to happen today. So not only are you going to look at the K value, that will still tell you whether it enlarges it or reduces it, but if you have a negative, notice it also rotated the figure 180. It does not change any sort of process or anything that we're going to do. Just recognize the negative is also going to rotate your picture. Everything else is the same, okay? So let me give everybody a chance to finish filling in all the blanks and stuff there. If you feel ambitious, start graphing the triangle in example 4. It's our next graph. Hopefully the graph gets copied a little better. All right, let's do it. I see some of you already have the triangle ready to go here. So let's graph it. Same thing, -4, -2, label. So process is still the same, but just recognize because on your scale factor, you have the negative, the half is going to shrink it, it's going to be half the size. The negative is also going to spin it 180 degrees. It's going to rotate it. Big deal, math is still the same. -4 times -1/2. Watch your signs closely always. -2 times -1/2 is +1. -2 times -1/2, 1. 4 times -1/2. Let's do H prime. Okay, so -2 times -1/2, +1. So when I graph this, it should be half the size and rotated 180. Let's see how we did. F prime, G prime. Okay, look, it definitely looks smaller. Looks half the size to me. And of course, if I take this and I rotate it 180, yeah, see it, you got it. So that's all the negative's going to do. So just be aware of that. It also will spin your figure. Big deal. Who cares? It's not exciting. Okay, let's do a couple word problems and be done with it. Read closely. You're making your own photo stickers. Your photo's 4x4. The image on the stickers is 1.1 by 1.1. What is the scale factor? So the question is, are you doing 4 over 1.1 or 1.1 over 4? That's what you're going to think about. Are you making your photo stickers bigger or smaller? Smaller. Okay, if you look at the picture, of course, it tells you we're making them smaller. We're going by 4 to 1.1. So we want that smaller number on top, bigger number on the bottom. Now, this is, I get to talk some algebra here. We never leave a decimal within a fraction. I got to clean this up a little bit. If I said, hey, read this to me, the top, I would say it's 1 and 1/10. So to clear out the 10th, I'm going to times by 10. But I got to do the bottom too. I got to keep this thing balanced. So if I multiply by 10, that moves the decimal one to the right. 4 times 10, 40. So that's just a little fraction. No, you can't have a decimal within the fraction. I just had to clean it up. So just be conscientious on which way you divide, of course. All right, last one. Here we go. If you are using a magnifying glass that shows the image of an object as 6 times the object's actual size, determine the length of the image of the spider seen through the magnifying glass. Okay, so let's set it up here. Now, here's what's fun. As they tell you, when you look at it through the magnifying glass, it's 6 times the size. So that's what you're supposed to equal. There's your scale factor. Now, the question is your lovely spider over there, okay, the 1.5, is that what you are ending up with, or is that what you're starting with? Does the 1.5 go on the top, or does it go on the bottom? I hear conflicting answers, my friends. Okay, all right, okay. So couple things here. Determine the length of the image. Now, when we do our scale factor, was it image over pre-image over image? Which is on the top? Image. So that's what we're trying to find. I don't know, I just threw X on there. They gave you the pre-image. Your original spider is the 1.5. We're making it bigger. Now you do a little algebra here, okay? How are you going to get x alone? How are you going to get rid of that over 1.5? Yeah. I don't know, you might need your calculator for that. What's 6 times 1.5? 9. And I'm going to label centimeters. So any questions on that? Okay, so